Hello, everyone. Thank you for coming to my presentation. My name is Lin Wei. Just like, thank you for the introduction. I don't want to repeat again. So the topic I'm going to talk is about what we utilize biochar to develop a new biochar-based controlled release nitrogen fertilizer. I'm not sure how many of you already have experience on understand how the crop grows, especially for example, like corn. Corn is the biggest crop in US, actually also in the world. So nitrogen is the most limiting nutrition for corn growth. If without nitrogen fertilizer, acting nitrogen fertilizer, actually the corn yield is really low. But right now, that's actually earlier that the presenter, I remember Cheryl, already mentioned that after a decade, even almost century, use a nitrogen fertilizer, especially synthesis fertilizer. Right now, the more we put in, actually the output is not the proportion to what we input. So we need to find a solution to solve this problem. Because right now, overuse nitrogen fertilizer has become a challenge in corn productions. You see, if we not appropriately apply nitrogen during the corn growth, actually causing many problems. During the corn growth, we can see at different growth stage, actually at different corn growth stage, the demand on nitrogen is quite different. At the beginning, almost no use. But the farmers, in practice, they apply before they planting. That is the issue. Sometimes after corn germinate and grow up, and then if have the nitrogen deficiency, the farmer have to apply the second time, even in some case, use the third applications. This is the challenge because we apply multiple nitrogen in the field, actually causing the high machinery and labor costs and low nitrogen use efficiency, and also causing environment issues. Here, I just point out a few the potential or risk when we overuse nitrogen synthesis fertilizer. No matter it's in terms of the economy result or the economic and environment result, actually they have many risks for overuse synthetic nitrogen fertilizer. We already see the consequences because overuse nitrogen synthetic fertilizer. For example, like the nutrition lost through leaching or volatilization into the air or run off from the surface, and then also damage the soil by damage the microorganism in soil. The nitrogen leaching already causing allergy plumbing or even the fish death and the water system eutrophications. Actually, more than 50, even 60% of the water body in the United States already polluted by the nitrogen escaped from the agriculture. So, in order to address this kind of a challenge, we propose a solution to solve this problem. What we thought is, because from this figure we can see, based on different growing stage, corn demand on the nitrogen is quite different. If we have a smart fertilizer, control the nutrition availability based on the corn growth stage, and then match the corn growth demand, we believe, we hypothesize, in this way, if we apply fertilizer in this way, we can significantly reduce loss and then improve the nitrogen use efficiency. Why use biochar? I think many of you already know that, and the early presenter already showed biochar is a good stuff for the soil, but how we can use, what is the result apply biochar actually really depends on the type, what type of biochar you use, and then how you use, and when you use the biochar. So based on this consideration, we are thinking if we combine the biochar with fertilizer and no need to change any practical system or machine system or practical method, the farmer can directly use biochar as just like a regular fertilizer. In this way, we can reduce the cost and very convenient to use and then improve the application of biochar. So based on this consideration, our project is to try to develop a cost-effective, environment-friendly, biochar-based controlled release nitrogen fertilizer so that we can improve the nitrogen use efficiency and improve the soil health for sustainable corn production. Here, we just only focus on corn because nitrogen is the most limited nutrition for corn growth. But actually, if this working, this solution is effective, we are thinking we can apply this mechanism into other plants, no matter it's wheat or potato or other crop productions. So in this project, we focus on 4 objectives. The first one is try to disclose the mechanism, how we control the nitrogen release and timely available for the corn growth. Secondly, we want to evaluate the sample or the prototype if they effective in corn growth through the greenhouse test and field trials. If this really works, have a positive response, we are going to optimize this processing so that we can produce cost-effective product. And then we also want to examine, after we apply this fertilizer into field, if any negative or positive effect on environment. That is the 4th object we want to do in this project. This is the method how we made the biochar-based controlled release fertilizer. Actually, one purpose we developed this product is we don't want to replace all the synthetic nitrogen fertilizer, because we know in many cases without synthesis fertilizer, actually we really difficult to achieve the yield goal, especially in corn productions. So we still want to use. The only purpose is we want to reduce or at least minimize use the synthesis fertilizer, and then mix with biosolid. Biosolid actually is either is the food processing, the sludge or the wastewater sludge, and combined with biochar. After that, we pelletize into particles, just like the size of urea particle. If you're familiar with urea, it means the diameter just small than about 5 milliliter, in that range. We want to do this, the reason is, just like I said, we don't want the farmer, the producer, need to change any application method. If you only just directly use biochar, we can see actually we have difficult even in the windy day and blow away, or very difficult how we inject or apply into the field, is it uniform or not. And then the farmer maybe need to buy new equipment or new tools. So that's why we don't want to do that. We want to just produce product into just like the particle size as urea. This already exists system can apply this new product. Here is what we test in water. We can find when we decide the formula and the coating layer of this particle, actually we can control the nitrogen release based on time. This means that is possible to make the nitrogen available timely for the available for the corn growth at different stage. You can see on the right side, that is our goal, our target, and this is the test in water. We can see, actually, that is possible to achieve this goal. After we made the particle sample, and then we already run in greenhouse test for the corn growth in greenhouse. Here is the result. We compare two different particles of our biochar fertilizer with control. Control, it means negative control, without any fertilizer additional fertilizer. And CCRNF is a commercial controlled release fertilizer. This actually is a controlled release fertilizer concept. It's not new. It's already available. Even have some product available in market. And then we want to compare the market, our fertilizer with the market product. AS is ammonium chloride. This is just a regular nitrogen fertilizer. And we run a few years. This is the best result we have. We run a few years, 3-year greenhouse trials, and then this is the best result we have compared to the control. Actually, you see, we already double, 2 times higher than the control based on the, our fertilizer, 2 different types, both performing pretty good. And compared to the regular nitrogen fertilizer, actually we still have 28% increase in corn yield. Or compared with the commercial controlled release fertilizer, we also have 13% higher in yield. Another good thing is, when we compare the increase in yield, we also can see biochar-based controlled release fertilizer can reduce the nitrogen loss in leachate. It means we can reduce the nitrogen loss for our product. You can see, actually, if compared to the regular fertilizer, we can reduce more than half loss. And compared to the commercial controlled release, we also have 24% less loss. Based on this positive result, right now we already running a pilot scale to produce our product so that we can run the field trials. This is the procedure how we prepare the biochar controlled release fertilizer in our lab. We already run 3 years field trials. Here's how we do the field trial. This is in 2 acre size. Compare every treatment have 4 replications. We test before and after apply the fertilizer. We test the soil property, and then during the corn growth, we measure how the corn growth respond to the fertilizer treatments. And then we harvest. If you have agriculture experience, you will know if when we do the field trial, actually many factors is out of our control. It's really depend on the weather and the soil condition, the year. Here is also the best result we got from the field trial. We run 3-year field trials. So we can see, actually our biochar fertilizer, compared to the control, we can almost double the yield. Of course, compared to the conventional urea fertilizer, we have 18% increase in corn yield. Even compared to the super nitrogen or the ESN. Is anyone heard this term before, ESN? Yes. That is right now, actually is have a good performance in market in terms of nitrogen fertilizer. But compared to that, our biochar fertilizer also perform better. We have about 4% or 5% increase in yield, even compared with ESN. So based on this result, actually right now we are looking for collaboration, and then we want to scale up. Of course, right now this is a very small field trial. We want to scale up the field trial to maybe 100, even 1,000. We are looking for collaboration, try to explore possible any other resource to collaborate. Actually, we also got the biochar from industry, especially from the Iowa producer, biochar producer in Iowa. We already tested is the oak horse biochar. Actually, we also want to test is the biochar made from wood chip or corn stover. So you want to see, the reason is cost is really an important factor we want to develop our product. That's why we want to, the target is want to produce is a cost effective. And different biochar have different, cost or price effect on the final product. Based on our cost analysis, actually right now, if we produce our biochar fertilizer in a commercial scale, we can control this product within $1 per pound. Definitely a little bit expensive than urea, but based on the biochar cost, the biochar is one of the major costs for manufacturing this product. So that's why I asked some producer, what is the cheapest biochar they can provide? If we collaborate, or that's why I come to this meeting and then looking for collaboration. If we work together and make this product, and then we can, I believe we should have a market for that. So that is the plan for our project. So I want to wrap up my talk at the end. We believe actually biochar is a very promising material to combine with synthesis nitrogen fertilizer, and then can achieve the goal of what we call 4R, stairship nutrition management. I'm not sure if anyone familiar with 4R. It means 4R is right source, right time, right place, and right rate. When we do the fertilization practice, we're supposed to have this 4R nutrition management stairship. So I believe our product is helping to achieve this goal. And this goal is, if we achieve this goal, that is what we call precision agriculture. And we can use less chemical fertilizer, synthetic fertilizer, and then storage the carbon into the soil, reduce the nitrogen or nutrition loss into water. We can improve the environment, at least minimize the environment impact caused by the chemical fertilizer. Actually, we are looking at, because the first presentation already showed that if we integrate biochar with microbial, soil microbial, actually that is another direction we are working on right now. We want to integrate with the plant growth promoting bacteria into biochar fertilizer. And then in this way, maybe we can eliminate use synthetic chemical fertilizer. In this way, it's really benefit the environment and the farmer and the producer. I think in this way is the pathway to achieve the sustainable corn productions. Also, why we said it's a promising method is because if we can control the cost, actually what we increase in the fertilizer price can be compensation by the yield increase. Even is profitable. We believe so. That's what I want to talk for today. And here, we really grateful to the funding support sponsor and also the research team. Thank you, everyone. Thank you. I think we still have time for any question, right? Okay.
Hi, that was an excellent presentation. So I'm kind of a fertilizer person by nature, so I have a couple questions. Just to be very clear, the fertilizer that you enriched the biochar was urea?
Yeah, right now we use combined with urea.
Okay, have you looked at other nitrogen sources beyond urea?
Sorry?
Have you looked at other nitrogen sources like ammonium nitrate or ammonium sulfate or any other like nitrogen sources other than your urea?
At current stage, we only focus on nitrogen. Actually, we're going to test how if we can combine biochar with the phosphate and potassium. We also want to do that.
Okay.
Yeah.
And
actually, why we don't want to put the NPK in one product is because it really depends on the demand of the field and the producer. You know, if we have a certain, only just one formula, actually not fit all the demand in field. We want to separate this only just on the nitrogen nutrition combined with biochar.
Okay, and then on top of that, I'm very familiar with ESN, and I think one of the claims is they really target the release pattern to match corn uptake. So I thought that was confirming, and also reduce the volatilization. So with that said, so when you were talking about the fate of nitrogen loss through that, like the leachate, did you also look at volatilization potential reductions with the biochar with urea?
Actually, right now the data I show here is only for the leaching.
Okay.
Reduce. We didn't have time to measure how much reduced in the volatilization loss yet.
Okay. And then I promise the last question.
No problem.
So again, great presentation. When you showed the longevity curves going up to like 45 days or something like that, do you think there's a way to manipulate the longevity to become even greater based on the biochar source?
That is a very good question. Actually, right now we test not many types of biochar. We only have some when we do run the greenhouse test, because the sample is not much we can produce by ourselves. After we go to the field trial, 100 pounds, actually we could not produce in our lab. And then that's why we bought this biochar from Iowa, the biochar producer in Iowa. So, yeah. Thank you. Yeah.
When you were comparing the different sources of nitrogen and the growth response, were you applying the same pounds of nitrogen per acre between all of those treatments?
Sorry, your question is about the acre or the soil type?
The pounds of nitrogen you were applying, were you equating the amount of urea that you had in your product to the ammonium sulfate being applied, or did you account for the extra nitrogen that was being applied from the biosolids too?
Yeah, very good question. Actually, you see, before we run the experiment, we already do the soil analysis. We already know how much nitrogen available or contained in the soil. Actually, based on the soil analysis, and then there will be a nitrogen apply rate, recommendation rate. In this way, actually, when we run the test, we not run on the 100% recommendation rate. We only just run at 80%. Even in field trial. For this product, when we compare the increase, just at the same nitrogen level. For example, if this soil type, based on the soil analysis, recommendation is 150 pounds nitrogen per acre, we only just apply 80% of this recommendation rate. And then the urea, biochar, fertilizer, all based on this 80% nitrogen recommendation rate. Based on this, it means at the same nitrogen level, compare the yield increase or the nitrogen loss. That is this result.
Okay.
We got this result.
So you added it based on the total nitrogen of your finished product, not the amount of urea contained in it?
No, we based on the urea nitrogen level. Yeah.
Okay. And how did you measure the release of the fertilizer to get your release curve?
Because we used the soil column. Soil column, a cylinder, a turbine, put in the soil, and then put in different sample, and then use water to swab up, and then collect the leaching at a certain day, at a certain, and then measure how much nitrogen lost into the leachate. And then we can compare, okay, at the same condition, the same soil, the same height, and everything just the same. And then see how much compared to different treatment or different fertilizer sample, the loss reductions.
Okay.
Yeah. Thank you.
Thanks. A great presentation. I have a follow-up question regarding the nitrogen. So you see a soil that needs, for example, 100 pounds of urea, right?
Yeah.
And then you say, okay, I will apply 80 pounds, like 80%, right?
Yeah.
And you mix urea with biochar and biosolid, you pelletize it, and you apply it. Is that correct?
No, actually, we just simulate how the farmer do in the field. We just use on the top, just like the farmer spray on the top soil, on the surface. That is how we compare, because you see our target is want to produce product so that the farmer can use in field. So how the farmer apply the urea, and that's what we do, what we did in the greenhouse test or in the field trial. Just apply on the surface of the field or soil.
Yeah, and how much do you apply per acre, for example?
Okay, that's a very good question. Actually, our biochar fertilizer have about 30%, 30 to 35% nitrogen content. Like urea is 46%. You see, if the urea recommendation rate is 100 pounds per acre, our fertilizer just about 150. I mean, a little more biochar fertilizer, not more much, because we have lower nitrogen content, just about 30 or 35%.
Thank you.
So actually, this is just a new type of fertilizer. Just in case, for example, if 100 pounds per acre is recommended, our product just about not more than 200, just about 180 or something like that. Yeah.
So
Yeah.
as a fertilizer label, so like ESN would be like a 4400, urea is 46.
Mm-hmm, yeah.
You're saying this would be like a 3000.
Yeah.
Okay.
Yeah, just like 30, or because we have two different samples, we want to see if we reduce the nitrogen content in the product 30 and 35%, and then just a 30, 0, 0, just like. Okay.
Hi, I have a quick question. Two
Yeah.
quick questions. First, when you did your biochar, you actually pelletized the biochar with the municipal biosolids, and then you coated that with urea. Is that what you did?
No. Actually, I can go back to the.
And my second question, real quick, was what
see-
ended up being your biochar application per acreage in your final BC and biochar natural fertilizer compound?
Okay. You see, this is the method how we made the biochar fertilizer. Actually, we already mixed, not only, we call it biosolid, it means it's a municipal waste or even compost or manure, and biochar and, for example, like urea. We mix together and then pelletize, and then coating with a controlled release coating layer. This coating layer is really magic. Can determine when and how much nitrogen can be released out of the particle.
So what's in your coating material?
We have tried different biopolymer. PLA is one of them. For example, we have tried different materials. Some is made by our own, use a cellulose composite. All is biodegradable.
So and just one more question. How much biochar ended up being in that whole, what's the percentage of biochar in
Okay, you see, actually, biochar is about 30 to 40% in the particle. Because we combine with the biosolid and urea and biochar, so about 1 to 1 to 1 ratio, but that's not an accurate ratio. Okay, that's a rough in that range. Yeah. Oh, okay. Sorry.
Thank you, Dr.
Okay,
Wei.